I think so. Definitely grade 8. Okay. Example. Very similar to yesterday. So, if you were confused, pay attention. Graph. Minus 2x plus y is greater than or equal to 2. Okay, I want to graph that. But it's not a line. It's like a shaded section. It's an inequality. Well, even in a line, there's an infinite number of solutions, right? Even from there to there, that's an infinite number of points. Because you can always get that decimal a few more places, right? But now there's like a whole shaded part. So what do I do? What did I do yesterday? First, I just treated this like I was in grade 10. Okay, I just said, that's my line. How do I graph that? And I could put that in y equals mx plus b form, but I'm not teaching it like that. Okay, I'm not saying that's wrong. If you want to do that, feel free. But some questions, it's going to be nasty. Because again, remember, your y-intercept isn't always a nice whole number. What if it's 2/9? Do you know what that means? So we're going to do x and y intercepts. Do this. Because even though I said it yesterday, some of you guys were still doing the algebra and then getting this number and going, well, what, Mr. Watson, what is this thing? Well, you don't even know what you're doing. Okay, you did it right, but you don't know what it is. Write it down. X-intercept. That's what I'm trying to find. What happens at an x-intercept? What's my y-coordinate here? Yes. Write it down so you know what the heck you're doing. Okay, then substitute y0 in there. Minus 2x and 0 is 2. Solve that for x. That's the x-intercept. So minus 2x is 2. How do I solve that thing for x? How do I get rid of negative 2? I know half of you are going, I want to add it. No, because that's negative 2 times x. You always do the opposite operation. I got to divide it away. So x is negative 1. Wonderful. Do you know what that means? What was I doing again? Oh yeah, that was the x-intercept. y0 there. I want a coordinate point, right? I want to plot this thing. So that's negative 1, 0. Here's my graph. Got 1 point. Just need one more, negative 1 and 0. And I can find out where this boundary line is, the word they use for it. So what's the other point I want to get? The y-intercept. What happens at the y-intercept? Always, always, always. I don't care if it's there, here, there. Whatever point crosses the y-axis, x is always 0. So let x be 0 and y is 2. That was easy. What's y? But that's not just any old y, it's the y-intercept. What's the coordinate of that point? 0, x is 0, and 2. Okay? That's what we do first. In grade 10, you would have went just like this. Don't do this. Wah. Done. Got a billion marks. There's arrows here. That goes forever and ever and ever. But now, it may not be a solid line. Is this one a solid line? It is. Because that's greater than or equal to. Okay? So, that's a solid line. Because it's equal as well. I don't know why I'm putting that as like a bubble, like a thought, but I did it. Okay, so I do want to make this a solid line. It's not greater than or less than, where the line isn't a solution. This, the line is a solution. So I do want to make that solid. Okay, just rough. Okay, good enough. I just want to, when I'm marking this, guys, I'm just seeing if the line's in the right shape and if you shaded the right side. Speaking of which, what is the side I want to shade here? How do I do that? Use a test point. And if you can use 0, 0, that's probably the one you want to use. Unless your line, if your line looks like that, it's not clear whether 0, 0 is, like, you don't know what side that is. So if you found out that it worked, well, what side do you shade, okay? So and then in that case, you'd use any other point. It doesn't matter which point you use, okay? You just want to check a point. Here, 0, 0 works. It's just the nicest one. I mean, I wouldn't want to use 100 and, I don't know, 19/4, right? For obvious reasons. Test. Test a point. Stuff it back in here and see if it works. If it does, it's in the solution area. If it doesn't, then it's not. So -2 times 0 and 0. The question is that greater than or equal to 2? That's 0. That's 0. Yeah, -0 is still 0. Someone asked me that yesterday. Is 0 greater than or equal to 2? No. So that means this is not in the solution area, which means I'm going to shade the other side. Okay? So I don't know if you had one like that yesterday, where 0, 0 didn't work. You remember? Did you? You did have one? Okay, good. Are we okay with that? Should I check one of these points just to make sure? Okay, let's check that point. That's supposed to be in the solution area, so it better work if I plug it in here. What's the coordinates of that? -3 and 2. So x is -3. So if I go -2 times x plus, what's y? 2, that had better be greater than or equal to 2. Is it? What's a negative times a negative? Yeah. Is 6 and 2 greater than or equal to 2? Yes. Bingo. It works. Okay? It's not a bad idea to double check. Just do another point. Okay? So that's what we did yesterday. Today, this is a little different. But it's still graphing. Line might be dashed, might be solid. Is this one dashed or solid? It is solid. It's equal to, okay? So again, if you got that, or you got that, greater than or equal to, less than or equal to, that's a solid line, okay? And if it's just that or just that, then it's dashed, because the line is not a solution. Okay? So, question is, what the heck's going on here? I said you want to get your x and your y-intercepts. Okay? So if you do that, what happens at the x-intercept? Y is 0. First I want to treat that just like an equal sign. Okay, so great. 0 is -2. What's going on? Yeah, you don't know. Here, y equals mx plus b might be a little helpful. That doesn't really help. That says y is, where's the x? There isn't one. Is that give me the same thing? Yeah. That says exactly the same thing as this, doesn't? Because anything times 0, it's gone. I don't need it there. And what does that say about my slope? A slope of 0 means horizontal line. So that's a horizontal line. Guess where? Well, what does that say? Y is -2. I don't care what x is. Y is -2 here. It's -2 there. Here, there, 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 there. The y-intercept's where x is 0, but there is no x. So the y-intercept is -2, horizontal line. And it's solid, okay, because that's less than or equal to. Okay, so that one's a little trickier, but you did see that in grade 10. Now you're seeing it again in grade 11. If this was grade 10, that's where I'd end, but I don't because it's grade 11. I got to shade aside. Can I use my 0, 0 test point? Well, why not? So I'm going to substitute x is 0 and y is 0. There is no x, but I can substitute a y. Is 0 less than or equal to -2? No, it's greater than -2, right? Would you rather have no bucks or owe $2? You'd rather have no bucks than owe $2. I don't know if that helps you or not, but anyway, 0 is not less than -2, it's greater than -2. That is not in the solution area. That's where we shade. But let's actually look at this again. What does that say in English? It says all the values of y less than or equal to -2. Is -3 less than or equal to -2? So that's a solution. All of this is a solution. Anything less than or equal to -2. So use a test point if you want, but common sense says that's the part I'm going to shade. This is all solutions. 1,017 points plus infinity. Okay? Same stuff, just a little bit different. This is going to be quite a bit different. Example 3. Bob works 3 times. Hey, are these words, guys? Ooh, does that mean it's a word problem? Excellent. Bob works 3 times as many hours as usual. What is usual? We don't know. Jen works twice as much as usual. Now I could put in here some other things that helps you make sense of the question, like it's summer and they work part-time all year, then in the summer they work full-time. Okay, make sense? I did. More words, right? Now, their employer requires them to not both work full-time though. They need to share. They both work less than, what's the name of this chapter we're doing? Inequalities. Does that say inequality? You bet. 40 hours a week. So that's one person full-time. That's a standard in the Canadian Labor Code. If you're in Bangladesh, there is no labor code. You could be 9 years old and work, and it's perfectly legal there. You can work 80 hours a week as a 9-year-old, and it's perfectly legal. And we're all happy for that, because then we can buy our t-shirts for $6 instead of 40, right? They work less than 40 hours a week together or combined. We'll put that word in there. Okay? So, we don't know how to really get this equation yet, so we will just write it. And in a question in the book, it'll look a lot like this too. So whatever Bob works, I'm going to let that be B for B hours. But at this particular time, it's 3 times as much, right? Does that kind of make sense? If he works normally 10 hours, then now it's going to be, well, you know what 3 times 10 is? 30. So if B was 10, this also says 30, doesn't it? 3 times 10, okay? Jen works. What do I want to put for a number here? What's another word for twice? Yeah. Whatever Jen normally works for hours, let it be J. I'm not writing all this down, I'm just saying it, okay? But I'm giving you the equation. I'm just trying to see how, trying to make sense of it. So I'm going to double that, because now she's working twice as much as usual. But they both have to work less than 40 hours. in a week. Doesn't say that. Oh, it does say that. I'm sorry. So what's how do you put less than? Yeah, you know. I know. Do you know? That's the question. That says less than. Makes like an L, right? L for less. Now, does the alligator thing help? Okay, so you're saying 40 is bigger than 3B and 2J. That's true. That's what it says. But it's a little tougher than little kiddie school, where like 6 and you got 2, and it's easy to see which one's bigger, right? You see what I'm saying? Okay, anyway, if it works, go for it. There's the equation. So, this is not just any old line going to infinity and negative infinity. There's some common sense stuff going on here. What are the restrictions on the variables? Well, what the heck's a variable again? It's a letter. It's what you solve for in grade 8 algebra. That x thing, right? In this case, it's b and j. Those are variables. We don't know what they are. They can vary. But could b be negative 10? Does that make any sense? Could j be negative 2.5? Does that make any sense in the context of this question? No, because what does b and j stand for? Hours that they work. Can you work negative hours? Like not show up one day and then you owe the boss 150 bucks? You should, but that's not allowed in this country. So what are the restrictions on the variables? B and J, it kind of needs to be greater than or equal to 0. Could it be equal to 0, either one of these? If one person goes on holidays and doesn't work at all, this could still work, couldn't it? The other person's just going to have to pick up the slack, right? Get called in for extra shifts. So there's another way to say that in English. How do I say greater than or equal to 0? Whole numbers? Does that ring a bell? Remember this natural number, whole number, integer thing? Okay, we're going to be doing that in this chapter too. Okay, so that's number 1. Graph. Using this common sense stuff. So when we graph stuff, like what does this coordinate mean? That's the first coordinate, that's the second, that's the third, and that's the fourth. Do I want to graph all 4 coordinates for this question? Why not? Because isn't this where x is negative? Doesn't really make any sense. So I don't want that. I don't want this. Is this one okay? Quadrant 4? I got negatives for y, right? I don't have x and y now. I got b and j. The only thing I want is quadrant 1. That's the only thing that makes sense here. So that's the only thing I'm going to graph. And how do I graph this? What are my intercepts? So, just the positive quadrant, which is quadrant 1. It's the only thing that makes sense here. There's no y, there's no x. Doesn't matter which one goes where. Let's put j there, and let's put b here. Pay attention. So, like I said, if b, who's that? Bob, doesn't work at all, how many hours could, geez, I got a memory like a sieve. Jen, how many hours could she work? Bob's on holidays. What's the maximum amount of hours Jen could work? But hang on, can it be equal to 40? Has to be less than 40. We're just going to make this, I know in reality you usually get paid to the nearest 15 minutes, right? If you work 8 minutes past the hour, you get paid for 15. If you work 6 minutes past the hour, they round it to the nearest hour. We're just going to round this to the nearest hour. Not every 15 minutes like the labor code, okay? So, nearest hour, she can't work 20 hours here because that would be exactly 40. So it has to be less than 20, and the nearest whole number less than 20 would be, yeah. So she could work, I'm not counting, I'm just putting a 19 there. If Bob works 0 hours, she could work 19, right? That's less than 40. Let's take the other extreme. Now she goes on holidays, or the boss is pissed off at her, doesn't want to call her in for work. How many hours could Bob work here? Well, I don't know. That's a lot of math. There is no 0.5s. 1.5. So he could work 13 hours and it would still be less than 40, right? That'd be 39. But he can't work anymore, and we're not doing quarters and halves of hours. So Bob, if that's 19, 13 should be a little less than that, so let's put it right here. If Jen works 0 hours, Bob could work 13. And there's all these combinations in between. But you know what? I don't need to plot and figure out each one of those, because that's going to make a line there between those 2 points. So do you see where the solution area is? Could they both work no hours at all? Would that be less than 40? Sure, that's a solution. Could Bob work 1 hour and Jen work nothing? Sure, that's a solution. How about that one? Yep. You see all these points here? Do you remember this term in Math 10 called discrete data? Right, because it's the nearest whole numbers. It's not continuous. So I don't want to shade that in. I want to, what's the word in the book? Who noticed? It kind of rhymes with like when you guys don't shave and they got this prickly stuff on their skin. Not stubble, it's stipple. Yeah, stipple. Almost sounds pornographic. I don't know why. I shouldn't have said that. Okay, so you want to stipple the area. It's just whole numbers. It's not continuous. It isn't all the decimals and the fractions, an infinite amount of points. It's just the whole points. Okay? No, you don't. Because you're going to ask me in 10 minutes, Mr. Watson, I don't take notes. I don't know what the heck you said, so can you help me with the first question? All right. Page 303. 3, 4, 5, C to F. I believe I gave you A, B yesterday. 5. Okay, now do the other guys.